Hi, thank you. I'm Carlos Oviedo. I'm a chemical engineer from LEDSS, and I'm going to show you a video that talks about what LEDSS is all about.
As a sustainable model to be followed. We have a situation on our hands. By 2050, the world population will reach 9 billion. With such population growth, the pressure to find natural resources needed to provide food and energy will increase. World economy is projected to require 80% more power to feed a growing population. Furthermore, cultivation land will expand over the next decade as a result of the demand for food, which will trigger a strong competition for scarce land in the coming decades. The inevitable end of oil and fresh water represents the greatest challenge facing humanity. Alternative energy is a solution to our problem. Other countries are investing aggressively in the development of technologies needed to produce sustainably, and Mexico has great challenges and great potential to launch systems that solve such problems. With this in mind, we want to channel our efforts in a smart way to maximize our resources and strengths. LEDSS, the age of the
And it's a project that was developed in Mexico, and what we created was an agropark high-tech. An agropark high-tech, well, I came here to talk to you about part of LEDSS.
We have a situation.
Okay, I come to talk to you about smart farms. Smart farms is a project of LEDSS, and it consists in monitoring and controlling an agropark high-tech. An agropark high-tech, it's the building itself where aquaculture and horticulture farming is made in the same space, one above the other. It has its Sonarda cooling system. This cooling system was designed by us, and it's patent pending, and it's necessary because the agroparks are designed to be located in the desert, near the ocean. And a key point of this cooling system is that it produces fresh water from salt water, actually allowing agriculture to take place in these lands. The agropark also has a built-in biodigester, a methane enrichment plant, and a power generation plant. All of these inside a vitro invernadero, which is a glass greenhouse. These are some of the aspects that need to be monitored and controlled by the smart farm system. First, we have our weather parameters, which they affect our cooling system and our biodigester process. Our cooling system is essential to give a good environment for our fish and our plants. Our plants' production affects our biodigester system. Our fish actually allow us to produce nitrogen-rich fertilizers, and we also obtain fertilizers from the biodigester process in a liquid form. Another output of the biodigester is methane, which is what we use to generate our power. And by doing so, we produce CO2. But this CO2 that we create, or we do not let it go into the atmosphere. What we use it is, we use it as a fertilizer, or all the fertilizers that we create goes into the plants. We enrich the atmosphere of inside the greenhouse, actually having faster growing plants and not allowing the CO2 that we're producing to get into the atmosphere. And well, the power that we generate goes into our cooling system, among other stuff. As we can see, this is a very complex system where all of the different processes are interconnected. So if one of the processes fails, the whole system will fail. That's what we need, a centralized controlling system. And that's what Smart Farm is all about. Smart Farm needs to work like the brain of the whole system. He needs to receive all the information of all the different processes in order for it to control it simultaneously. And that's what we're working on. When we started developing this system, we saw that most of the equipment for monitoring and controlling that is on the market has already a specific use. For example, we bought a weather station for the purpose of capturing all the climatic information that affects our system. But we soon realized that it wasn't a good fit for us because we couldn't get the information in the time lapse that we needed in order for the cooling system to work. It also already came with its own software, which was designed for traditional agricultural needs, and we just couldn't integrate it in the whole system. So the solution for us was to work with LabVIEW and NI hardware. With these two key elements, we can create an application customized, designed specifically for our needs. We can integrate all the sensors and actuators that we need to create a centralized controller, and that's what we're working on. Our goal is that by the 21st of December of this year, we build our first agro-park high-tech, a first hectare, where we can continue to develop smart farms, and where we can start a new age, the age of the sixth sun. Thanks.